Hi, I'm Matthew Brown, and I'm a paleontologist here at the University of Texas. As director of the Texas Vertebrate Paleontology Collections, I'm very fortunate in that I've had the opportunity to participate in almost every aspect of our field. I've been able to travel all over the world collecting new fossils from remote locations. I've been able to work with the specimens back here in the laboratory and in the research office, and I get to collaborate with a diverse team of researchers from all over the globe. One topic that's very interesting to me is the history of science, and I spend a lot of my time documenting how we've made discoveries in the past, how we reconstruct and then study those specimens in the laboratory, and then how we represent them to people in the general public. So I get to spend a lot of my time working in laboratories, in archives, and in historic collections, looking through old field notes, looking at old field photographs, sometimes watching movies that were made in the 1930s or 40s that were showing people in the field collecting specimens. I got my start in paleontology as a high school student. I was volunteering in a local laboratory at the University of Chicago, and one of the first animals that I got to work on was a brand new dinosaur called Suchomimus. Suchomimus was a large meat-eating dinosaur found in the Sahara Desert. And after we spent about a year cleaning the bones and reconstructing them, we unveiled the specimen to the world for the first time at the National Geographic headquarters in Washington, D.C. So when I was about 16 or 17 years old, I got to fly to D.C. and take part in the unveiling. After working at the University of Chicago, my next stop in my professional career was a few miles up the road at the Field Museum. I was hired to work at the Field Museum on the Sioux project. Sioux is a 42-foot-long dinosaur that had been found in the 1990s in South Dakota. Working on Sioux was definitely one of the most fun parts of my career. I was able to learn an awful lot about paleontology, about fossil preparation, about molding and casting, making replicas of bones in a very short window of time. This is a bronze cast of one of Sioux's largest teeth. I helped make the silicone rubber mold that this bronze cast is made from, and I continue to use this technique in my career more than 20 years later. Making rubber molds and plastic casts of fossils is an important way for scientists to be able to share information about very fragile specimens that we might not necessarily be able to ship to people who want to study them. This is also an important technique to be able to publicly display fossils that might be too fragile to put on exhibit. Before we can study fossils, we often have to excavate them from the rock in which they were collected. Here you can see that process taking place as lighter red rock is removed from darker red fossils. After several million years in the ground, these fossils are typically very broken up, and we have to restore them in the laboratory by gluing these broken bits back together using archival adhesives. Here you can see this crocodile skull being reassembled, and then we make a secure cradle for the collections cabinet. These rows of cabinets are organized geologically by time and then geographically by locality. We estimate that we have approximately 2 million fossils stored in this building spread across 3 floors. One of the final steps in the scientific process is publishing our results in peer-reviewed technical journals so that colleagues around the world can study them. I hope that you enjoyed this look at what it's like to be a vertebrate paleontologist, and if you want to learn more, you can follow along on our social media @TexasVertPaleo.